Good morning, class. Today we shall proceed to the next topic of this chapter, Force and Laws of Motion, Chapter 9, Class 9 Science. Previously we have studied Newton's first law of motion, Newton's second law of motion, and various terms, momentum, inertia. Okay, as you have attended the previous classes, you must know that what is first law and what is second law. First law, Newton's first law, as it says that an object remains in a state of rest or in uniform motion in straight line unless or until compelled to change the state by an external unbalanced force. Okay, this is the exact statement you need to learn because each and every word is important. Uniform motion in straight line. No, speed should not change. Velocity also should not change. Straight line motion. Right? Compelled to change the state by external unbalanced force. Force should be unbalanced. That has an effect. So that is first law of motion, which generally means कि जब तक फोर्स एक्सटर्नल फोर्स अनबैलेंस्ड फोर्स आप किसी ऑब्जेक्ट पर नहीं लगाएंगे तब तक वो अपनी स्टेट डायरेक्शन या स्पीड चेंज नहीं करेगा. दैट इज फर्स्ट लॉ. सेकंड लॉ टेल्स अबाउट द वैल्यू, हाउ मच फोर्स यू नीड टू अप्लाई to change the state, and that depends on the momentum, right? Force depends on rate of change of momentum. More momentum you require, high rate, more force you need to be applied, you need to apply, right? You know that momentum is product of mass and velocity. Okay, so more change in velocity if you require in less time, so rate of change of momentum is high, you need to apply more force, and vice versa, right? Both are interrelated. Okay, now we come to the third law of motion, which you might have never heard before or felt, but that is truth, that is universal truth, that every force you apply on some object, किसी भी ऑब्जेक्ट पर कहीं भी आप फोर्स अप्लाई करते हैं, instantly at that moment that object also applies equal and opposite force on you. Okay, listen carefully. When an object applies a force on another object, the second object instantaneously, simultaneously applies equal and opposite force on first object. ठीक है? Think about this. जब भी आप कोई फोर्स किसी भी ऑब्जेक्ट पर लगाए हैं तो इट डज नॉट मीन दैट वो ऑब्जेक्ट कुछ नहीं करेगा, चुपचाप बैठा रहेगा, वो ऑब्जेक्ट भी आप पर फोर्स लगाएगा. दैट इज द मीनिंग ऑफ थर्ड लॉ. फॉर एवरी एक्शन देयर इज इक्वल एंड अपोजिट रिएक्शन. एक्शन, you act on an object, the object reacts. It will react. It will not stay silent. It will not stay still. It will also react. You act, they react. For every action, there is an opposite, equal and opposite reaction. Okay. So think about some examples. Can you think about such examples? कभी कहीं भी आपने फोर्स लगाया तो आप पर भी एक फोर्स इक्वल एंड अपोजिट लगा. Think about this. When this happens, now you might be confused. कुछ स्टूडेंट्स के माइंड में आ रहा होगा कि अगर फोर्स इक्वल एंड अपोजिट है तो फोर्स जीरो होना चाहिए, जैसा कि बैलेंस्ड फोर्स में आपने पढ़ा था. बैलेंस्ड फोर्स में यू हैव स्टडीड दैट इक्वल एंड अपोजिट force act on same object, then it is zero. Then why this force is not zero? Why force is not zero if every force and equal and opposite reaction? There might be this question in your mind, but there is one point you can think about this. कुछ ने सोच भी लिया होगा कि I said equal and opposite of forces. A applies force on B, B applies force on A. ठीक है. For example, आपने किसी को पुश किया, उसने भी आपको पुश किया. ठीक है, दोनों फोर्स इक्वल थे मान लीजिए, तो बोथ ऑफ यू विल मूव, बोथ ऑफ यू विल गेट अ पुश. ठीक है, बिकॉज अलग अलग ऑब्जेक्ट पर फोर्स अप्लाई हुआ है. बैलेंस्ड फोर्स में क्या था, इन बैलेंस फोर्स एक ही ऑब्जेक्ट पर इक्वल अपोजिट फोर्स अप्लाई होगा, ठीक है, दैट वाई इट इज जीरो, इट डज नॉट मूव। बट इन एक्शन रिएक्शन थ्योरी फॉर थर्ड लॉ ऑफ मोशन देयर आर two objects and they apply force on each other, this on this and this on this, okay। सो हम एक ऑब्जेक्ट की बात करते हैं तब देखते हैं फोर्स एक पर जीरो है, लेकिन ये अलग अलग फोर्स जो है अलग अलग ऑब्जेक्ट पर अप्लाई हो रहा है, ठीक है। तो दोनों पर फोर्स अप्लाई होगा, ऐसा नहीं है कि दैट विल बी जीरो, नो, देयर विल बी सम वैल्यू ऑफ फोर्स ऑन ईच ऑब्जेक्ट, ठीक है। So that is, you always remember that every action has an reaction, equal and opposite reaction, but these forces act on different objects. That is why you cannot say force is zero. Okay, so that is third law of motion. So now think about some examples which prove third law of motion. First and most interesting example is how you walk. How you walk. When I am walking, what I am doing? Am I applying force in air or something else? Okay, आपने बहुत बार you walk every time, but you might never have noticed that you applied force on which object. Walk again now and think. See, you are applying force on the land, on the surface you are walking. There you are applying force. You notice that you are applying force on the surface you are walking, okay, then you can understand that you apply force on the land, on the surface, and the floor applies equal and opposite force on your legs. When you are walking, you are pushing the land, the floor from your legs, then the floor applies equal force on your legs. That is why you get a push in forward direction. Forward direction because you are applying force in backward direction. आप surface को, floor को पीछे की तरफ धकेल रहे हो. You are pushing the floor backwards. That is why you are moving forward, right? So direction opposite है. You are pushing the floor in backward direction and the floor is pushing you in forward direction, equal and opposite, right? When you throw something, आपने कुछ भी थ्रो किया, आपके पास बॉक्स है, you threw it in forward, then you feel a force in backward direction because box, you applied force on box in forward direction, the box applied force on you in backward direction, right? There are so many things. Can you think of some more examples? Action reaction forces. There are so many examples. Think of a balloon, a filled air. Air is filled in balloon. Imagine this is a balloon. Air is filled in it. And you are holding its mouth by your hand. As soon as you remove your hand, जैसे आप अपना हाथ हटाते हो, तो air comes out of this. Air applies force in this direction, forward direction, right? You can say balloon applies force on air in forward direction. That is why air comes in forward direction. ठीक है? So at the same moment, air also applies force on balloon in backward direction. That is why balloon will go backward. जैसे ही आप बलून को छोड़ोगे अपोजिट डायरेक्शन में दूर भागेगा, ऐसा होता है। दैट इज वाई, बिकॉज इट इज ड्यू टू थर्ड लॉ ऑफ मोशन, बलून अप्लाइज फोर्स ऑन एयर एंड एयर अप्लाइज फोर्स ऑन बलून, अपोजिट डायरेक्शन. दैट इज ऑल्सो वन एग्जाम्पल. ओके, think of more by which you can understand. More example, look at this. Do you know what is this? This is a spring balance. Okay, this is a device that measures weight, balance. It is kind of balance. इसका भी आपको weight measure करना होता है. That you put it here and it comes downwards and the value can be measured here in grams. Okay, so what we are doing in this, we are taking two spring balances and we will study what happens when one applies force on another. Okay, so one end we tie to a wall or some rigid support like this, and if you could see that initially value is 0 on both sides. As long as A applies force on B, you can see the readings on the both scale. readings are exactly equal and opposite. It means a force A applies on B, B also applies equal and opposite force on A. Okay, that's how you can imagine the force, action and reaction. Force applied by A on B is action and force applied by B on A is reaction. Okay, equal and opposite forces. So that is how you can understand. Okay. Another example, bullet and a gun. Okay. When gun is fired, what happens? Gun applies force on bullet in forward direction. Gun ने bullet को forward direction में force apply. Okay. Both high velocity से you know that velocity is high, that is why change in momentum is high, so it is very harmful. That is why it hurts, because bullet comes in very high speed, so impact is more. So वो आपने second law of motion में कर लिया है. अभी हम बात कर रहे हैं कि when gun applies force on bullet in forward direction, तो जब भी आपने दिवाली पे या कहीं भी छोटी मोटी गन आपने फायर की होगी तो उसमें देखना गन भी बैकवर्ड डायरेक्शन में मूव होती है. Why gun comes in backward direction? Because bullet also applies force on gun. Gun applies force on bullet, bullet on gun. That is why it comes in backward direction. Okay. So that is called recoil of the gun. Recoil means gun का वापस आना. Recoil of the gun. ठीक है. Now one question may arise in your mind. अगर ये question आपके mind में आया है, that it means you are in the right path, you are going good, that अगर बुलेट इतनी आगे तक जाती है तो गन इतनी आगे तक क्यों नहीं जाती, राइट? या फिर आप किसी भी चीज़ को पुश करते हो, वो इतना आगे जाती है तो आप उतना पीछे क्यों नहीं जाते? लाइक फोर्स जो है, आपने इक्वल एंड अपोजिट पढ़ा है, इक्वल फोर्स है तो जो डिस्टेंस है, वो जो एक्सेलरेशन है वो अलग अलग क्यों होता है? एक चीज़ बहुत आगे तक जा रही है, बहुत तेज़ स्पीड से जा रही है, दूसरी चीज़ बहुत कम स्पीड से थोड़ी डिस्टेंस तक ही पहुंच पा रही है. व्हाई इट हैपन्स? यू फॉर आंसर दिस यू नीड टू रिकॉल सेकेंड लॉ ऑफ मोशन, जो मास का कॉन्सेप्ट है, F इक्वल टू एम, मास एंड एक्सेलरेशन, हाउ दे आर रिलेटेड. इफ मास ऑफ एन ऑब्जेक्ट इज लेस, ओके, एंड इक्वल फोर्स इज अप्लाइड ऑन टू ऑब्जेक्ट्स, but mass of one object is less, another object is more, then acceleration of light object will be more, right? Velocity of light object will change more in less time. That is why gun do not come backwards in with so much speed, right? The acceleration of the gun is much less than the acceleration of the bullet. So force may be equal, लेकिन it does not mean कि acceleration equal होगा. Acceleration depends on mass of the object. So if you have the force are equal, you need to consider mass, right? There are so many examples, so many events you can see. It's also given in your book, NCERT book. Then when a sailor jumps out of a boat, sailor जो होता है, नाविक जो होता है, जब बोट से बाहर आता है तो वो it pushes the boat backwards and it comes forward, right? Equal and opposite forces. Okay. और when you एक टेस्ट ट्यूब है, टेस्ट ट्यूब में आपने वाटर फिल किया है और कोर्क से उसको बंद कर दिया है. When you hit the test tube, तो water vapors will be formed. Water vapors will push the cork, जो cork होता है जिससे उसे बंद करते हैं, in forward direction. Cork will come out and the test tube will go in backward direction. So that is also example. एक diagram में आपको example which can show it written in your book. I can show you through this book. The two children are playing a game. They are pushing a bag towards each other and standing on wheels. So one boy is throwing a bag to the girl. Okay. So obviously due to the force, girl will go in backward direction. Also the boy will also go in backward direction. Force इसने apply किया, लेकिन ये भी backward direction में जाएगा क्योंकि इस पर भी फोर्स लगेगा, इक्वल एंड अपोजिट. इसने बैक पर फोर्स लगाया तो बैक ने भी इस पर फोर्स लगाया, राइट? सो बोथ ऑफ देम व्हेन व्हाइल प्लेइंग दिस गेम विल गो इन बैकवर्ड डायरेक्शन. बोथ ऑफ देम विल गेट एन इंस्टेंट रिएक्शन. दैट इज ऑल्सो एन एग्जाम्पल. ओके. सो I hope you have understood something about third law of motion. Statement, action, reaction. Second thing, equal and opposite. Both are equal and opposite. Still they are not zero. Why? I have told you. Third, that why their velocity change is not equal. Okay, why their acceleration is not equal? Because that depends on mass. So force may be equal but acceleration will be different. So that is the third law of motion, right? So if you have any doubt, you can ask in class or write in comments.